Welcome back. Let's learn how to solve inequalities using properties of multiplication. Alright, so in the last lesson, we learned how to solve inequalities using the addition property of inequalities, but now we're going to take solving inequalities one step further. Because with just the property of addition, we cannot solve inequalities like these that we would want to solve. Right? Our goal when solving inequalities is to get it in the form of a solution set where you just have a variable followed by an inequality sign and then a constant. But with these inequalities right here, there is a number in front of the variable or a coefficient that is preventing these inequalities from being in that form. So in order to solve these inequalities or get their solution sets, we would need to remove those coefficients. All right, and so just like with solving equations, when you need to remove a coefficient of a variable, you need the help of properties of multiplication. Right, in each of these inequalities, you can't get rid of the coefficient of the variable of x using addition or subtraction. The only way we're going to be able to remove them is via multiplication or division, just as we learned to do with equations in a similar form. But there is going to be a twist for inequalities. Removing a coefficient from a variable in an inequality will be similar, but not always done the same way as it would be for an equation. And so let me explain. Starting with an equation, this is an equation that we learned how to solve earlier in algebra. To solve this equation 2x equals 4, we would want to get rid of this coefficient of 2 from the variable of x, which we can do by either dividing both sides of the equation by that coefficient of 2 or multiplying both sides of the equation by the reciprocal of that coefficient. Okay, so you could either divide both sides by 2 or you can multiply both sides by 1/2. And so by doing that, 1/2 times 2 is just 1. Those two constants cancel each other out. They multiply to be 1, and 1 times x is just x, so you get x is equal to 4 times 1/2, or you could think of it as 4 divided by 2, which is 2. And x equals 2 is the solution to this equation. If you substitute in 2 for x in the original equation, you have 2 times 2, which is equal to 4. Okay, and so that's how we would solve an equation like this, and we would use that same exact process no matter what that coefficient of x was, right? If we change that coefficient, let's say it's -2 times x is equal to 4, we would still solve this equation the same way. It's just that the coefficient is now different, so we would change the number that we divide both sides of the equation by, or the reciprocal that we would multiply both sides by. All right, in this case, we would divide both sides by -2, or you could think of it as multiplying both sides by -1/2. Okay, and so -1/2 times -2 would just be equal to 1. Those two constants cancel each other out. You'll get 1 times x, which is just x, and x would be equal to 4 times -1/2. Or you could think of it as 4 divided by -2. Either way, you will get -2, and so x equals -2 is the solution to this equation. You could substitute -2 back in for x in the original equation, and -2 times -2 is +4. The equation would be true. Okay, so again, my point here is that it didn't matter what the coefficient was in front of the variable for an equation, we use the same exact process. We know that we can multiply or divide both sides of an equation by the same value, and the solution to that equation will not be changed. That was the multiplication property of equations. And the reason I'm pointing this out is because this won't always be the case for inequalities. And so that's what I want to demonstrate next. Let's just start with a very basic inequality that doesn't involve any variables, right? Just consider the inequality 6 greater than 3. That is a true inequality. 6 is a bigger number than 3. Let's say we want to multiply both sides of this inequality by the same value, and we use a positive number. For example, let's say we multiply both sides of this inequality by 1/3. Let's see what happens to the inequality. Will it still be true? Well, 1/3 times 6 would just be 2. You could think of it as 6 divided by 3. That is 2. So we get 2 greater than 3 times 1/3, which would just be 1. 3 divided by 3 is 1. So after multiplying both sides of the inequality by the same positive number, we get a statement that is still true, right? 2 is greater than 1. That is true because 2 is a bigger number than 1. So multiplying both sides by a positive number seems to work just fine, but watch what happens if we multiply by a negative number instead. right? If we use the same inequality here of 6 greater than 3, but instead of multiplying both sides by positive 1/3, let's multiply both sides by negative 1/3. What will happen now? Well, 6 times 1/3 is still 2, but now there's a negative sign to account for. So 6 times negative 1/3 will give us negative 2. And then if we drop that inequality sign, we'll have negative 2 is greater than 3 times negative 1/3, which will be negative 1. Right, you could think of this as 3 divided by negative 3, which is negative 1. And now look at the resulting statement that we get here. We have negative 2 is greater than negative 1. That is not a true statement, right? That is false. Negative 1 is bigger than negative 2. Negative 2 is a smaller number compared to negative 1. And so when we multiplied both sides of the inequality by a negative number, all of a sudden the inequality is no longer true. But it would be true if we flip the inequality sign, right? We could fix this error by having a less than sign instead of a greater than sign. Now we have negative 2 is less than negative 1, which is a true statement. All right, this is a very important property of inequalities. What we've discovered here is that if we're going to multiply both sides of an inequality by a negative number, or you could think of it as dividing both sides by a negative number, you have to also flip or reverse the inequality sign so that the statement is still true. You don't have to do that for positive numbers. If you multiply or divide both sides of an inequality by a positive number, you do not need to change the inequality sign. The statement will still be true, but if you do use a negative number, you will have to flip the sign. This becomes extremely important when we want to solve inequalities where we need to use multiplication or division to remove a coefficient of a variable. Okay, so let me demonstrate that for you. Let's actually look at an inequality now that has a variable we want to solve for. Let's consider the inequality 2x is greater than 4. If we want to solve this inequality for x, or get the inequality in the form of a solution set, we need to get rid of that coefficient of 2, which we could do by dividing both sides of the inequality by that coefficient of 2. You could also think of it as multiplying both sides by 1/2, but this time around I'm just going to divide both sides by 2. And so these 2's will cancel out, and you'll get x is greater than 4 divided by 2, which is 2. And so x is greater than 2 is a solution set we get for this inequality, but does that solution make sense? Well, let's test it out. If we pick a value of x greater than 2 and plug it into the original inequality, let's see what happens. I'll choose x equals 3 because 3 is bigger than 2. In the original inequality, you'll have 2 times 3, which is 6, and 6 is bigger than 4. So that checks out. You could also look in the opposite direction. If you pick a value for x that is not greater than 2, that would make this inequality false. The same thing should happen for the original inequality. So if we pick 0, 0 is not greater than 2, that would be a false statement. You should get the same thing up here. And 0 times 2 is 0, so you get 0 is greater than 4, which is not a true statement. So this solution would be correct. The solution set to this inequality was not changed by dividing both sides by a positive number. X is greater than 2 is the right solution set. But now what if we had a slightly different inequality? Let's say we had negative 2x is greater than 4. In this case, in order to solve for x, we would want to divide both sides by that coefficient of negative 2. So let's do that here. Let's divide both sides by negative 2. These negative 2's will cancel out, just leaving you with x. And now, just for the sake of this demonstration, I'm going to leave the inequality sign alone for right now. So we'll have x greater than 4 divided by negative 2, which is negative 2. Okay, now we do want to flip this inequality sign, but I still want to show you why that's the case when we're working with a variable in an inequality. Because when we don't flip this inequality sign, the solution that we get here is different than what the actual solution set should be for the original inequality. All right, what we found here is that x would need to be greater than negative 2, but is that actually the case? Well, let's pick a number bigger than negative 2 for x and plug it in here. 0 would be a number that's bigger than negative 2. So if we plug 0 in for x here, you'll have 0 times negative 2, which is 0, and so you'd have 0 greater than 4, but that's not a true statement, right? That would be false. And so the solution set that we found here doesn't seem to be correct. And you could test other values as well. You could pick negative 1. Which is a value of x bigger than negative 2. If you plug negative 1 in, negative 1 times negative 2 is positive 2, and positive 2 is not greater than 4, so you would also get another false statement. Okay, so my point here is this. When we went to solve this inequality and we divided both sides by a negative number, but didn't flip or reverse the inequality sign, the solution set that we got is incorrect. What we have to do to make it correct is flip it or reverse it. Instead of a greater than sign, we will have a less than sign. And now the solution set is correct. Okay, values of x less than -2 will make the original inequality true. For example, let's pick a value of x less than -2. Let's say -3. -3 times -2 would be +6, and +6 is greater than 4. So that checks out. Values for x less than -2 will make this inequality true. All right, we had to flip that inequality sign since we divided both sides by a negative number. And that would be the case for any type of inequality. Whether the original inequality had a greater than sign, a less than sign, a greater than or equal to sign, or a less than or equal to sign, no matter what it is, if you multiply or divide both sides of that inequality by a negative number, you have to flip or reverse that inequality symbol. And so altogether, what we have looked at here is the multiplication property for inequalities. There's two parts to it. The first part is that each side of an inequality can be multiplied by the same positive number without changing the solution set of the inequality. All right, and that does include division because division is defined in terms of multiplication, right? You can view dividing by a number as just multiplying by the reciprocal of that number. But if that number is positive, you don't have to worry about changing the inequality symbol. The solution set will be unchanged by multiplying or dividing by a positive number. But then the second part is that if each side of an inequality is multiplied by the same negative number, and that also includes dividing by the same negative number, and the inequality symbol is reversed or flipped, then the solution set is not changed. Okay, that's very important to remember. You can't just multiply or divide by a negative number to solve an inequality. You also have to flip or reverse the symbol when you do that. That way the solution set is not changed and your answer is correct. Okay, and so now that you've been introduced to the multiplication property of inequalities, let's close out this lesson by looking at a few examples of solving an inequality using this property. First up, we have 2x is greater than 8, and so in order to solve this inequality, remember what our goal is. The goal when solving inequalities is to get the variable by itself or isolate it on one side of the inequality. And so in this case, to do that, to isolate x, we need to get rid of this coefficient of 2. And to do that, we want to multiply both sides by the reciprocal of that coefficient, or you could just think of it as dividing both sides by that coefficient. Okay, and if it's negative, you do want to remember to flip the inequality, as we've talked about a couple times now. All right, so in this case, the coefficient is +2, so we don't have to worry about reversing or flipping the inequality sign. We can just divide both sides of the inequality by 2, and we'll be good to go. These 2's will cancel out, just leaving you with x is greater than 8 divided by 2, which is 4. And so x greater than 4 is the solution set for this inequality. And if you wanted to, you could also graph that solution on a number line. It would look like this. If this number line represents the values of x that are in the solution set, then it would look like this. I'll label the center with 0, and then we're comparing x to 4. So we have 1, 2, 3, 4. I'll put 4 right here. And 4 is not included in that solution set because it's x greater than 4, not greater than or equal to. So we'll draw an open circle at 4 and then draw an arrow in the direction of numbers greater than 4. So that would be numbers to the right on the number line. Okay, so that would be my graph or my plot of this solution set on a number line. And so we have finished this example. Let's take a look at another one. Hey, real quick, before we get to the next part of this lesson, if you find my videos here at JK Math to be helpful, then I'd like to invite you to join my membership site JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you'd get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. Okay, so if you're interested in becoming a member, feel free to check that out, as it's a great way to support me in the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. For this example, we are given instructions. We want to solve the inequality and graph the solution set on a number line. All right, and we have 3/4 times x is less than 6. And so to solve this inequality, we have to get rid of this coefficient of x, and the coefficient is a fraction this time around. It is 3/4. And so to get rid of that, we can either divide both sides of the equation by 3/4, or when you're working with a fraction, I think it's easier to think about using multiplication. We'll just multiply both sides of the inequality by the reciprocal of that fraction, which would be a fraction where you flip the numerator and denominator. Okay, so we want to multiply both sides of this inequality by 4/3, right? If you flip the numerator and denominator of 3/4, you get 4/3. So that is the fraction we want to multiply both sides by. That is the reciprocal of 3/4. All right, and so by doing that, 4/3 times 3/4 is just 1, because these 4s would cancel out and these 3s would cancel out. Anything divided by itself is just 1. So you're just left with x is less than 6 times 4/3. So let's simplify that. 6 times 4 is 24. So we get 24 divided by 3, which gives us x is less than 8, because 24 divided by 3 is 8. All right, and that would be the solution set for this inequality. Notice that we did multiply both sides by a positive number, so we did not need to flip the inequality sign. It stays as a less than symbol, and we're good to go. We just want to graph this solution set on a number line yet, so I'll draw my number line here. I always like to label the middle with 0, and in this case, we're comparing x to 8. And so let me label that. We have 1, 2, 3, 4, 5, 6, 7, 8 right here. And 8 is not included in the solution set. It's x less than 8, not x less than or equal to 8. So we'll draw an open circle at 8 and then point the arrow in the direction of numbers less than 8, which are numbers to the left of 8 on the number line. Okay, and so that's it for this example. Let's take a look at one more for this lesson. For our last example, we want to solve the inequality and graph the solution set on a number line, and we're given -5x is greater than or equal to 9. Okay, so to solve this inequality, we need to get rid of the coefficient of x, and notice this time that it is a negative number. So when we get rid of this coefficient of -5 by dividing both sides of the inequality by -5, we have to remember to flip this inequality sign, or reverse it. We can't leave it alone because we're going to be dividing both sides of the inequality by a negative number. Okay, so let's do that here. We're going to divide both sides by -5. These -5s will cancel out, just giving us x, but then don't forget to flip the sign. So we'll have x less than or equal, not greater than or equal, to 9 divided by -5, which doesn't really simplify nicely. I'm just going to leave it in that form of -9/5. And that will be the solution set to this inequality. Okay, and so then don't forget to graph it on a number line. This time around, we are comparing x to -9/5, which if you put that into a calculator, it's -1.8. And so if this is -1 and this is -2, then -9/5 is somewhere about right here. And we are including that value in the solution set because x is less than or equal to that value. So I'll draw a closed circle at that value and then point the arrow in the direction of values less than that value, which would be numbers to the left. Okay, and so with that, that is it for this lesson. But if you do want to get some more practice solving inequalities using the multiplication property, feel free to check out my examples video for this topic that I'll have linked here on the screen. If you have any questions, please let me know in the comments. But if you don't have any questions, this is all I had for now. So I will see you next time.